So next we're going to talk about hypothesis test portion, but why we do it and what's involved in it. Before that, we need to find another statistic. So we're going to talk about the statistic first, which we will need in the hypothesis test. So we saw that SSE is equals to sum of I from 1 to n yi minus yi hat squared. That was the sum of squares due to error. So it can be expanded to yi minus e0 plus b1x whole squared. Still SSE. So another term that we need from this is called MSE, which is mean squared error. Mean square error, also MSE. And MSE is nothing but SSE divided by n minus 2. Why n minus 2? So n minus 2 is degree of freedom, and we subtract it by 2, subtract n by 2, just because we need two terms to calculate SSE. So b0 and b1 for any given x, we need those values in order to be able to calculate SSE. That's why we divided by n minus 2. And MSE is also s squared, we'll see why, over n minus 2. And S is the standard error of the estimate, which is going to be what? Simply root of s squared, or you can say root of MSE, and that is SSE over n minus 2. Basically, we had to come to this conclusion here, find this value of standard error of estimate, because we're going to need it. So far what we've done is just we know what SSE was, the formula for that. We divide SSE by n minus 2 over here. That gives us MSE, which is mean squared error. It's also denoted by s squared. We just take the square root of s, which gives us the standard error of the estimate, and we're going to need it. Why? We're going to look further, because we need to calculate that statistic I was talking about. Okay, so next thing, since we know that this is the actual model looks like that, right? But we don't know the actual model because we don't know the values of beta naught and beta 1. So what we do is we find the estimated equation, right? b1x. Now my point is, this is, let's say this is the equation when we take one sample. Let's just take a value. Let's say y hat is 2 plus 3x when we take the first sample. And then we take another sample and we find the estimated regression 9. And let's say it comes out to 1.9 plus 3.1x. This is with the second sample. Take another sample, say we find the values 2.9x. Third sample. So keep on doing that. We keep on finding different values of b0 and b1 here, right? So basically b1 or beta 1, because so b1 is the estimator of beta 1, and since we're getting all of these different values, it kind of tells us that beta 1, the real beta 1, it has a distribution, and we're trying to understand the sampling distribution of beta 1 through b1, which is the estimator of beta 1. So the sampling distribution of b1 is what we're going to look at. Why b1? Because we don't know beta 1, right? So we don't know what the sampling distribution is. We're just trying to predict what it's going to be. So we have to understand the behavior of the estimator to know what the behavior of the actual value is going to be. So the expected value of b1 is going to be beta 1. That's the hope. That's how stats works, right? So the expected value of b1 is beta 1. Then the standard deviation of beta 1, we're going to denote it with that, is equals to that over that. Now we probably already know this, right? But like we're familiar with this, we kind of expect that. But the standard deviation of B1 is given by this here, and this quantity here is not essentially known to us. So we do what we do best in stats. We find another estimator for this value. And we're gonna call that SB1. And SB1 is that. And this is going to be the estimated standard deviation of B1. Now so why are we doing all of this? Is so to try and understand the distribution of B1, right? The expected value is beta 1, standard deviation is given by this equation here, and because we don't know what sigma is, we're going to find another estimator for sigma. This is the estimator of sigma, SB1. It's also called the estimate. So this terms, let me take another color here and get rid of a few of these. So this here is also called the standard error of B1, and this essentially gives us estimate of standard error of B1. Why we need it, we'll get to know. It's just that for now we need to know that this is the standard deviation of B1. It is also called the standard error of B1, and this here is the estimated standard deviation of B1, also called the estimate of standard error of B1. So I hope we've seen how we've gotten here. So initially we had SSE. From SSE we found MSE, also called S squared. Right, from that we found the value of S, which is the standard error of the estimate, right here, right? And why we needed S? Because we wanted to find the estimated standard deviation of B1. So from that we have found SB1, and from SB1 basically it's estimate of sigma, and we need that to understand the standard deviation of B1. So that was the whole point. But these values that we found here are going to be helpful in doing the hypothesis test, because we have to find what the t value is going to be, and to put values in that formula we will need these values. So before doing that, in the next video I'll also talk about hypothesis testing, because we have all probably forgotten how to do that. So we'll just go through a brief overview of hypothesis testing, and then see why we're going for t-test and not the z-test.